For the people who just walked in, holy cow, that's a lot of people. Do we have any seats for them? No? Sorry. The room is pretty packed. You guys could, you could take floor space if you don't mind sitting on the floor up here, that's fine. Just because you can't really see standing back there. But anyway, for the guys who just came in, there's a bucket moving around, and I see it with the guy who right there. There you go. Throw your business card in there. If you don't have one, write your own business card on anything, piece of paper you find, and you can win. It's not up there anymore. You can win the drone that used to be up there. There you go. Thank you. So we'll just keep that bucket moving around, and we're going to get started right now.
Cool. Let's do it.
I'd like to introduce our awesome speaker of the evening. He formerly held key roles at both Mazda and Yamaha. Please welcome the CTO of Grindr, Lukas Sliwka? Sliwka.
Thank you. Quick sound check because I don't know how much I need to project. Do you guys hear me in the back? Yeah? Okay, so this is good. I'm not going to lose all my voice by the end of the evening, which is great. Quick question for everyone. How many people here actually write code? Okay, awesome. So I write code as well. The organization Grindr is very small. There's only 15, 20 people, but we support a large network of guys, and I'll talk about what Grindr is. Today we're gonna, if you don't know, today we're gonna talk about how to scale your mobile app. I'm gonna be focusing on Redis specifically, but also we're going to be talking about cloud architecture concepts and how to scale your infrastructure globally. And that's important if you're actually targeting a global audience. So what is Grindr? For two people in the room who don't know, Grindr is essentially a gay dating hookup app. It started in 2009 by a guy named geo-social. He's actually CEO of the company. He's also probably the biggest user of the app. In 2009, he was sitting in his living room, and he was essentially trying to figure out how to disrupt gay space. And at the time, meeting gay guys was very difficult. There was really no online tool to do it. And obviously, doing it in the bars on the street, you don't know who's gay. So he was actually solving a real problem. At the time, he really didn't know what he had on his hands. He started the company with $5,000. He never took any investment. So there's no VCs, there's no one really that controls what we do. It was all very organically grown. So it's one of those success stories that I sometimes listen to and I'm like, oh my God, that's crazy, right? Today, when he started actually, he's not a technical guy. He doesn't know what Redis is. He doesn't know how to code. So what he ended up doing, he essentially contracted out a whole bunch of work to contractors in Europe and in the US. And what ended up happening is that the initial release of Grindr started on PHP. So it was PHP backend, and he released iOS up. And he didn't know anything about scalability, so he was working with those developers, and he was like, okay, well, so how do we release this thing? So these guys were like, okay, well, you need to go to the hosting company and find a company that supports LAMP stack, and you need to just buy their introductory hosting plan, and that's what they did. So they launched this thing, and it just took off. So literally within a couple of months, they ran out of bandwidth on the plan that they were at. So what ended up happening, he's like, okay, well, we're down, what do we do? And they're like, oh, don't worry, we're just gonna upgrade to the silver plan or gold plan. And they kept doing that for the next 6 months, and then they reached the platinum level plan, and then the servers were down because again, someone mentioned Grindr in Europe on the show, and it started exploding worldwide. So he's like, well, what do I do now? And the guy's like, well, you're pretty much screwed because you got to do this clustering thing, and yeah. So it was kind of a lot of things when it comes to scalability with businesses like that and planning your architecture. A lot of times you always keep playing catch up, right? Because the growth is so fast, the business is driving the engineering. And I'm sure you find yourself in situations all the time where you don't have enough time to design stuff, to plan for stuff. And really what comes to the rescue today is a lot of technologies that are out there that can enable you and your team, especially when you start using managed services. And I'll talk about that, why that's important, to essentially allowing you to play catch up and also extend your engineering organization by making those strategic partnerships with managed services companies or companies that are specialized in certain things. So Redis is an example of technology that we use very heavily from the very beginning. The PHP stack was short-lived. PHP lasted about probably a year and a half before they essentially had to go back to the drawing board and redo things. And when they redid things, they tried to do it in Java, but for whatever reason that didn't work at the time. And they scrambled for some other stack that would scale. And they built the Grindr 2.0 on Ruby on Rails, right? So it was a Ruby on Rails application. We've got a big fan right there. And the Ruby on Rails backed up by some managed services like Amazon RDS as a database, Redis cluster, very, very heavily scaled Redis cluster up to the 2.0 platform used in-house managed Redis, 110 shards, each shard scaled to be able to process around 1,000 transactions per second. So the cluster itself was able to process in total 110,000 transactions per second with very low latency. So technology itself is very, very powerful. You can do a lot of different things with it. Why it's important to use something like Redis, I'll get into that a little bit further in the presentation. But the bottom line is latency, right? The latency kills you. And the moment you have a piece of your infrastructure that cannot handle the pressure that's coming from the world, latency keeps stacking up, and you end up having hotspots in your infrastructure or failing. So that's enough about Grindr. Now, talking about Ruby on Rails, we're actually transitioning off Ruby on Rails, and we're actually moving to Java and Scala. So the new backend actually launches this week, and it's essentially the stack is Scala fronted by Akka framework. So we don't have to deal with all the complexity of Scala, but essentially we leverage heavily the non-blocking I/O notion of Akka, and then we write our business services using Java, right? And that is all deployed into Elastic Beanstalk. We use Zookeeper to manage the infrastructure, and we pushed very heavily into infrastructure as code. So everything is done through Amazon OpsWorks and CloudFormation and Chef recipes to kind of manage this whole thing. Yes?
I don't know if you're going to talk about it later, but can you discuss why you decided to transition away from
I can address that now. So the reason why we're transitioning off Ruby is because Ruby is very expensive to run in a high performance environment, right? It's a fairly single-threaded model. So the number of servers that I need to have to support this application, it's crazy in comparison to the number of servers in the infrastructure that will power the Java Scala framework. I will reduce my infrastructure costs, hosting costs by probably 2/3 by transitioning off that technology, right? Which is important, right? So nothing against Ruby. I think Ruby on Rails, Ruby is an awesome technology. It has its place, right? It's very easy to build applications with. So as a startup, it's very attractive technology. There's a lot of people that are very good at writing good Ruby, high quality Ruby code. And that's also something that you need to concern yourself with, because you need to find these people to write that stuff. But at some point, you're going to start hitting fairly significant costs if you stay on that stack, right? Okay, so let's talk about the use case that we're gonna be addressing today. So, as a Grindr user, I want to be able to reliably access Grindr service around the world and to have a consistent user experience, right? Very, very easy, right? So again, what I want as a business user, I essentially want to have an application that can run in the US, China, Australia, Europe, and essentially have the same snappiness when you're using it, right? So let's talk about Grindr and what that means to us, right? So here's the essentially a distribution of our user base, right? So the majority of our users are in the United States. The second group is in Europe, and then South America. If you were to add those three markets, we've got probably 80% of our user base. The rest of people are, Asia, Australia, and Africa. Now, why I'm pointing this out, I'm going to talk about latency and performance and why technologies like Redis are important. Grindr has grown as business very organically. There's no marketing team. We don't have campaigns in Asia or Brazil or some other places where we have a dedicated team that does advertising, trying to people sign up. This is all word of mouth business. And at the time when Grindr launched, it was really solving a significant problem for the gay community, right? And that's why it kind of spread like wildfire around the world. However, and a couple other facts here. So over 40 million downloads. Yeah, we're over 200 countries in the world. One thing that I want to talk about here is that all this user base, we have right now around, I would say 7 million monthly active users. At any given point, we have probably 800,000 people online. So all that stuff results in pretty significant traffic on your infrastructure, right? So all these people are essentially generating around 10,000 API calls per second to our RESTful APIs, right? In terms of chat messages, we process around 85 million chat messages per day. There's a couple other facts there. I want to make a distinction here between the infrastructure that supports RESTful APIs and the infrastructure that supports our chat cluster, right? So those are two different sides of the house. Those are two different protocols. So obviously RESTful APIs are stateless HTTP. What we use for our chat cluster is essentially stateful XMPP protocol. We are using something called Mongoose IM, which is the enterprise version of eJabRD. And that is actually not running in the cloud. One of the first things that I did, I moved it away from the cloud because this is a very good example of infrastructure that doesn't like the cloud very much. Cloud today still has variances in terms of CPU available to you, variances in terms of network. This very, very high volume, high transaction rate, stateful infrastructure is very sensitive to that. So the moment you have any sort of variances on the network level, you can cause catastrophic crash of the whole cluster, and that has happened many, many times. A couple of years back, and we had to actually rebuild the whole chat cluster from scratch, which is not fun if it's New Year's Eve and you're trying to have fun. But the RESTful infrastructure, it is running in the cloud. We are using Amazon services, and that infrastructure leverages the 2.0 was leveraging a lot of the by hand managed configured cluster. So the old Redis that I was talking to you about was actually maintained and managed by internal DevOps team, along with a whole bunch of other infrastructure pieces that I'm going to talk about later on. So let's talk about latency. So this is our user base. The unfortunate part about old architecture was that, again, there was no much forethought put into like, okay, well, this is a global company, so I'm gonna launch it in US East region on Amazon Cloud, and then all this traffic from around the world ends up in this one place, right? So let's talk about, let's show what that does to the latency of the app, and this is essentially a measure of just one main API. If you actually ever download Grindr, if you're using Grindr, you know that when you open the app, you have essentially tiles of people around you. Our business is essentially allowing you to see who's around you, who's close to you that you can meet, right? So there's this get nearby profiles call that the client makes. And essentially response time to that call is very important because your user experience depends on how quickly you get that geospatial tiles of all the people around you. So if you're in the United States, everything is happy. It's sub-second, up to 200 milliseconds response. You start moving away a little bit. In Europe, that's around half a second. South America, 0.8. You start moving to Africa, Asia, Australia, you're in around 2 second response time. Now you start adding any sort of latencies due to your cellular networks. Again, this is a mobile app, right? So you could be driving, switching cell phone towers. There's a lot of noise that happens. This is measured on a Wi-Fi best case scenario. So you start adding those type of noise to your experience, and the app becomes unusable, right? One thing that we take for granted is that we expect certain user experience in our mobile devices by now, right? It is not acceptable for me to wait long time for things to come back and load, right? The moment I experience that, I just move on. There's plenty of competition out there. There are other apps out there that I can use, right? So it is very important when you're building and designing your cloud infrastructure to, number one, set up a test harness that is able to measure those things from all over the world. There are companies that you can partner up with that can help you with that. And again, I lean towards managed services a lot. Let me talk about that. Let me talk about managed services as we're here. One of the biggest pressures, especially in today's market, is hiring the right team, right? Hiring the right people who can actually build this thing, right? And it is very difficult to assemble a team of experts that can do it all, right? If I'm using Redis, if I'm using RDS, if I'm using MongoDB, if I'm using a whole bunch of other pieces of the infrastructure, if I want to have all that expertise in-house, it is very, very difficult as a startup to assemble those people under one roof to be able to create something like this. So the reality is, if you're trying to build something like that and you need to scale it globally, the first thing that you need to do, in my opinion, is you need to start looking for vendors that provide those services, right? So there are vendors out there that are able to essentially extend your engineering team. Obviously, you'll have to pay the money, but they're going to extend your engineering team and provide you the expertise that you need to build that stuff. One of the things that I had to do very quickly when I started with Grindr a year and a half ago was to stabilize the infrastructure, right? It was really running very hot. They had daily outages. There was a lot of pieces of the infrastructure that were reinvented from scratch. I'll give you an example. I could not believe that they actually built their own geospatial infrastructure to answer the question, who's around me, right? There's plenty of products out there that do it very well. MongoDB is one, for example. It uses the standard open source Google geospatial algorithm. Grindr decided to build themselves. The reason why they did that was because at the time there was not enough engineering oversight. There was no governance in terms of architecture, right? Developers were left to kind of do whatever they wanted to do. And what ended up happening, I'm an engineer as well. I want to play with cool stuff. I want to build cool stuff, right? So you need to be very careful when you're building your infrastructure to invest the time of the people that you have on stuff into pieces that create competitive advantage. as opposed to reinventing the wheel, right? I don't want to build, I'm not in the database space, I'm not in a geospatial search space. I want to be using, I want to be dedicating my stuff towards building pieces of the infrastructure that no one else has, right? And then for the rest, I want to be partnering people to help me do that. So again, with a small staff, we very quickly partner with several different companies that allowed us to replace a lot of this homegrown infrastructure, and we stabilized the platform within like, I think 5 months. But one thing that I want to say is when I think about DevOps capability, it is very, very necessary for what we do, right? But I'm very realistic about the fact that I will not be ever able to hire full-time DevOps staff and provide 24/7 NOC and monitoring, and then have DBA on staff and Redis expert on staff. You need to kind of partner with someone who can help you with that, right? So we partner with Redis Labs for a couple of reasons that I'm going to talk about later. The cluster that I described that served 110,000 queries per second was awesome, right? But it required a high DevOps footprint, right? I needed to have engineers to constantly tweak things, look at things. If that thing went down, it was a disaster, right? So I don't want that headache. I want to be able to build stuff that allow guys meet faster, as opposed to screwing around with Redis and understand all the intricacies, how to configure it, right? So Redis Labs is one of the companies that provide that service, and we've actually transitioned our Redis infrastructure to them. We tried Amazon, but Amazon could not scale to the level that we needed, right? So Amazon is great, but we've run into some snags. We moved to Redis Labs because we needed to squeeze that extra performance out of it, right? So again, this is not ideal. Everything ends up in the US East region, right? So we needed to fix that. So the first thing we did was, okay, what do I do? So we said, I'm going to start distributing my cloud infrastructure around the world, right? Amazon, again, is a great example of a cloud provider that is able to bootstrap your engineering team and give you the right tools to be able to do this, right? In the old days, if you needed to build your own data centers and provision the hardware in all these different regions, I mean, it's a nightmare, right? Today, you can do that fairly easily by using the different regions that Amazon has. They also have enterprise support that you can purchase. They can extend your engineering team with engineers at the right time if you need to, right? So what we ended up doing, we ended up creating 5 different regions, and we said, okay, I'm going to start using something called geo-routing. There's something called Route 53 in Amazon, which is a DNS-based geo-routing capability that they give you that says, okay, it looks at where you're coming from, and it essentially has rules that route your request to an appropriate region. And there are different tiers. You can add other things there, like you can chain your policy and say, okay, I'm going to first start with the geographical-based policy, then I'm going to look at maybe at the health of my data centers, right? So the idea is that at the global scale, ideally you want to design cloud infrastructure that is elastic and high availability, right? So if one of the regions goes down, then the other regions should be able to pick up the traffic, right? So when you're designing your routing policies, you want to be starting with the geo-routing, and then you can build in other rules there, right? Which is important. And then the next thing that you need to now start worry about is, okay, so now I have all these different data centers around the world, which is great. But now I'm essentially, I need to figure out how I need to replicate the data, right? And that's when it gets really difficult. And I'll talk about how we do that. But before I go there, I want to also show you what this setup did to our response times, right? So you remember the graph that I started with. So now the response times look like this, right? So what we've achieved essentially was I have the same response time on my APIs. It doesn't matter where I am in the world, right? I'm grinding on Grindr in New York. I hop on the plane. I fly to Sydney. I get off the plane, and I'm grinding, right? And it's the same response time, same snappiness. It's very important. We didn't do anything in Africa because we have a very small user base. We may actually deploy another data center there, but the juice wasn't worth the squeeze at the time. And you know, 0.8-second response time is still acceptable.
Where would that be based out of?
What's that?
If you did deploy there, where would you
South America. Right. Okay. So we achieved that. Now let's talk about this picture here. And the reason I want to focus on this is yes, that solved our problem in terms of response time. But when you look at this diagram, you see all these red veins still coming back to the US East region, right? Which means that if this goes down, then the whole thing goes down, right? So we needed to solve that, right? And I want to talk about some technologies that we're using. So we are using Redis very heavily. We are using SQS, SNS, SQS infrastructure, which is essentially queuing, pops up type of infrastructure. This is actually an outdated slide because we've moved away from Amazon. We're using something called Cloud AMQP. It's a RabbitMQ based, very, very fast Erlang stack, very similar to XMPP server stack that we're using. We've actually partnered with a company called Erlang Solutions who wrote the book on the thing. They are developers in Poland. And they're essentially helping us to manage a lot of that stuff. Cloud AMQP is essentially it's another managed services company that specializes in very fast, highly scalable, distributed RabbitMQ clusters, right? So again, going back, I don't want to be hiring, well, it's not that I don't want to. I'm having a very difficult time hiring RabbitMQ experts. So I needed to partner with someone who does that for a living, right? So Amazon RDS, we will be phasing that puppy out also. Amazon DB, DynamoDB. So that's where we are transitioning to a lot of this stuff. And then also we have MongoDB. So MongoDB replaced this crazy infrastructure that I talked to you about at the very beginning. So we're actually using Mongo to power our geospatial search, a whole bunch of other things as well. And then we're using there's a highly tuned MongoDB cluster that we had to actually tune in-house in our own infrastructure. That serves around, I want to say, close to 100,000 geospatial queries per second. So it's also highly tuned. But we needed to partner with Tengen and MongoDB to do it, right? So again, I didn't have MongoDB experts. I had to go to Tengen, had to buy enterprise support. They gave us engineers, and that's how we were able to do that. For other MongoDB uses that are not as mission critical, they don't have to be scaled so well, we're using ObjectRocket. At the time, we evaluated a whole bunch of different managed Mongo service providers. ObjectRocket was one of them. Incidentally, ObjectRocket ended up being bought by Rackspace. So I'm like, great, we made the right decision. But speaking of Mongo, I'm also moving away from Mongo because of the fact that scaling Mongo in a global, as a global cluster to start getting into geo-sharding and having, geographically distributed cluster with a couple of shards here, a couple of shards there, a couple of shards there, and designing your keys in a way so you have appropriate routing is very, very difficult as well. It's not It's a very, again, heavy DevOps, great technology. If you have the engineers to do it, power to you. But we made the decision to move away from Mongo for that reason, right? And then we are actually going to be moving to Elasticsearch, and we're using a company called Qbox that's managed Elasticsearch provider. So again, same theme. Partner with someone who does this for a living. I don't have to hire a whole bunch of guys who are Elasticsearch experts, and we can move on. Now, let's talk about how this works. So the one thing that powers this whole thing are local Redis clusters that are set up in those data centers, right? So if you look at this picture, not all infrastructure is actually replicated to all these different regions, right? The only thing that we replicate are actually these Redis clusters. And we are using essentially queuing infrastructure, pub/sub infrastructure to replicate data, right? So if you think about it, all my writes still end up on the east coast of the United States, but majority of the reads are actually happening from the local data centers, right? Which means that if I have an infrastructure that is very heavy read-oriented, right, then I'm good to go, right? So if you profile your application and you find yourself in a spot where 80% of your transactions are retrieving data, then this will work very well, right? However, if you have an infrastructure that is heavy write-oriented, that's not going to work, right? You will have to do some other fancy things like setting up multi-master databases and have multi-master replication and all the goodness that comes from like actually trying to make that work, right, on the global scale. Very, very yucky stuff. Okay, so again, we talked about all this data being available from Redis, very low latency, very, very fast. I'm able to serve most of my stuff out of Redis. Let's talk about latencies in terms of replication. So the way it works, the write comes in, and I'll show you sequence diagram, simplified sequence diagram, how it works. The write comes in, and what ends up happening is that you essentially have a transaction boundary when you say, okay, I'm going to commit to some sort of database, and as part of that commit, I'm also going to publish onto a topic, right? And what ends up happening is that all these different data centers, there are different topics for various different type of data. They all subscribe to these topics, and the moment write happens, you publish to a topic, and essentially the state gets distributed. There are consumers in all these different data centers that are listening for all these events to happen, and as the event happens, they update Redis, right? So nothing happens instantaneously. There's probably 30-second lag between you making an update and actually that update making it all the way through all the different data centers. It is okay for us because we're a geospatial application and we serve people who look for people around you, right? So when I'm in Sydney and I'm updating my profile, right, it's okay that these guys don't see my update probably 30 seconds. Probably it's okay if they don't see it for another hour, right? Because it's not I'm going to teleport myself magically over here, right? So it works for us. Again, it's a use case that works for us. You have to kind of look at this. If you have an application that is very sensitive to actually data being distributed at the same time, now you're getting into, again, multi-master commits. You need to have distributed transactions that essentially negotiate commit state across different geographical regions. It's yucky stuff, right? Okay.
Question?
Yes.
Can you clarify that? Because it sounded initially like you were saying all the rights went back to the US. Mm-hmm. But are you actually doing local rights and then propagating the change?
Correct.
And then sort of repropagating that out?
Yeah.
Okay.
So you have your primary data source, right, which resides over there. And then all that stuff here is just a copy.
Okay, but if I update my profile in Sydney, I'm updating it in the Sydney Elastic.
No, you're updating it here.
Okay.
So you're updating it here.
So how do you know what to propagate that just to Sydney?
No. It propagates everywhere. Right. So we don't have, and you can tune those policies. You can tune those policies, but if I only propagate to Sydney, thank you, and then I decide to fly to Moscow, and that state is not there, then I have a problem.
Right, but I'm highlighting a concern that if you're in Sydney and you update your profile,
Yeah.
and I don't fully understand the features of the application to
Sure.
know what that means, but it seems like you're still subject to a delay before a
So
profile update is
that
available.
that is a great question, because now what I was going to talk about also is about how you design your mobile clients, right? So when you design your mobile clients, and we don't do mobile web, right? So we don't do the HTML stuff and JavaScript and responsive. We may get into that later, but not right now. So all that stuff is native mobile clients. So when you're designing your mobile clients, you need to take under account the fact that your architecture is essentially using a different write pool from the read pool. Right? And when you're building your infrastructure that way, there's always going to be delay, right? It could be milliseconds, but there's going to be also a delay. So I'll give you an example. We had this bug where a developer was actually using a write pool to store information, and then for whatever reason, one line or two lines of code down the line, he would reread that information. Right? So, okay, easy enough, right? I mean, you're persisting, you're storing the stuff, and I stored my stuff, and I want to reread it. Well, it's all great, except that your infrastructure is set up in a way that you have a write pool and a read pool. If you write to your write pool, it takes milliseconds to replicate to all the replicas, right? So if you reread it, then there's a chance that stuff is not gonna be there, and you get like this undeterministic type of behavior where, like, when you're testing in QA, your cluster is small, you don't have the pressure of all the transactions going in, so you may not detect that problem, right? But you go into production, all of a sudden your customer service line blows up because 30% of the users save their stuff, and they're like, oh, where's my stuff, right? So this is kind of similar thing where we are writing here, but the clients are written in a way that I'm assuming that as long as I get the 200 OK from my write transaction, I don't reread it. I don't make another call to a RESTful service to get that data back, because I'm like, okay, I updated it. I updated my headline. I called the RESTful API to store that. I got an OK. So as an application, I'm going to trust that this state is going to be saved. So what I'm going to start displaying now is a local copy. Right?
So if you're in a cafe in Sydney,
Yep.
you update your profile,
Yep.
the person across the table from you won't see that for maybe 30 seconds or so.
Correct.
Okay.
Yes. Exactly. Okay.
And it's okay, or you want to get away from this kind of?
No, it's okay. For our use case, it's fine. I don't care. I don't care.
I mean,
if
if we are in North America, yes, but if we are in Sydney, it's
well,
it doesn't sound like.
I mean, it's one of those things where, like, okay, so I updated my profile headline. Is this business critical information that needs to be replicated at the same time, right? I mean, from the engineering perspective, it's.
I would assume if it's the same region, then probably yes, it's much more important if you are in Sydney that you will first update something that close to Sydney than to North America or Ireland.
Could you speak like that?
The short answer is I don't care.
Sydney.
Right.
Okay.
Like from the engineering perspective, I could spend a lot of money to try to solve this problem, but why? This is a dating service. If the delay is 30 seconds, right?
Right.
But yeah, it's not perfect.
So again, this speaks to like the application itself and the feature set. I would
Yeah.
imagine that your chat infrastructure doesn't work that way.
No, chat
Because 30
infrastructure-
seconds
yeah.
would not be acceptable.
Correct. So again, the reason why I don't made a distinction is because chat user experience is very different, right? It's very real time. It has to happen right away, right? If I'm chatting to you, the delay is unacceptable. Even 5-10 second delay if people responding to you, psychologically we're already thinking, oh, he doesn't want to respond to me. How many of you are actually using online dating? Come on. Tinder? No?
Yeah, Tinder.
Okay. So the chat infrastructure, I'll take your question in just 1 second. So chat infrastructure is very important to have that user experience where things are designed, architected, and built in a way so it doesn't matter what area of the globe you are, you have that very snappy experience. In fact, we are releasing new chat update this summer, and we're actually going to be providing advanced chat features that we all take for granted, like, oh, I know that my message was delivered to the server, delivered from the server to the client, with all these different indicators. We'll be able to see that someone's typing, right? We'll be able to see chat markers that someone read my message. So all that stuff is going to be built in. You'll be able to disable some of these features if you want to fly stealth, right? Which some of us do. But yeah, like that's why we're using stateful XMPP protocol that is kind of designed to facilitate high volume real-time transactions around the world. Right. Question.
Two-part question regarding chat. Using WebSockets as the interface for chat, and also can you talk a little bit more about the separation between the write pool and the read pool, and the
Yes. Okay, so chat infrastructure. So we're actually it's a TCP/IP level connection that happens. That is using it's using sockets, but I'm not doing any sort of socket level programming, right? I'm actually leveraging standard XMPP libraries that are out there in the wild. They're open source libraries, and we've actually extended them to add to them some features. We're actually going to be giving back to the community and adding those features to open source. Right. And what was the second part?
The reasoning behind the separation of the write pool and the read pool, and how you synchronize the data back.
Okay, so why would you? Okay, so the reason why you want to separate is because as you scale your infrastructure, right? You start with maybe with just one database server, right? But the moment you start scaling and you need to start now adding servers to essentially provide more connections, more capacity, what ends up happening is that you very quickly find out that your writes are very expensive and reads are not, right? So a lot of database infrastructures, what end up happening is that you have one master, which is kind of the source of truth for your data, and that's where you want all your writes to go to. And then you add these slaves that essentially replicate the state, right? And then the way you want to relieve the pressure of your master, right? So what in a high availability, high pressure type of system, what you end up happening is that you may have single master and let's say 10 slaves, right? Or if you find yourself that you need to have a lot of writes, then you start adding a multi-master setup with a whole bunch of slaves, right? But from the complexity perspective, having a multi-master setup is very costly and expensive to set up, right? However, the moment you start separating your infrastructure like that, you essentially create two different pools. You have a pool for reads and you pool for writes, right? And then your application has to be written in a way to utilize those pools correctly, right? Because if you essentially get a connection from your read pool and you try to write to it, that's not going to work. Right? Yes, sir.
First, thank you for coming out. Second, when you sort out vendors, you talked about instead of having expertise in house, you sort of looked out house. What were the biggest, I guess, challenges in terms of selecting or identifying vendors? Two, when you reached out to your vendors, did you present them with what you wanted, or did you present them with problems or challenges you're facing and they gave you solutions for them?
So both. So I'm going to start with the second part because I remember it. So usually what we do with vendors, we go through a essentially RFP phase where I select 2 or 3 different vendors, and then I say, hey, build me a prototype, right? So I'm like, hey, here's a problem, and that's usually a pre-canned problem that I have, and then I'm gonna say, okay, how fast can I implement it, right? What is your expertise like? Can I interact with your engineers very easily? Are you guys pleasure to work with, right? I mean, you would not believe, like, there's a lot of vendors out there that are just dicks, right? And I don't want that. So there, what I do is I'm a very metrics-driven guy. So I have a spreadsheet of like, here are the criteria that I'm evaluating on, and here are the vendors, and I'm just kind of checking off all that stuff, right? And then we make a selection. What was the first part?
Well, the first question was, when you went to the vendors, once you identified the vendor that you were going to use, did you say, hey, this is what I want, like this is exactly what I want you to build, or did you say, hey, these are the challenges or problems that we're facing, what solution would you
So I always start with a straw man, right? So I always present them like, hey, here's what we're thinking of building, right? And then I'm very, very open for them to come back and shoot holes in that solution, right? Because again, I think that starting from nothing is very dangerous, because what ends up happening is that they're gonna try to sell you everything, including kitchen sink, right? And you don't want that, right? So you want to start with, you know, some sort of a strawman architecture or use case that say, hey, this is what I want to build, and use that as a base to kind of grow from. Right? Okay.
Oh, just follow up to that point. In those scenarios, did you find that they actually took the straw man and grew from it, or did you ever find a situation where that was thrown out and replaced by a completely different solution?
Yes.
Okay.
Yes, it did happen where solution that we were proposing was inadequate, and we needed to go with something else. So it does happen. The reality is that, you know, this is a very complex ecosystem of all these different vendors, and the moment you start dealing with a high level of traffic, you know, you may not be aware of all the advances in the world. You may not be aware of certain technologies that are out there, right? These guys do it for a living, so a lot of times they come back to you and be like, hey, you know, you should be using this as opposed to that. Mm-hmm. And that changes your architecture a lot, right? Okay.
Two other quick follow-ups. The chat is an important part of many apps at this point. I mean,
yeah.
Just curious, were you able to find a vendor that would have offered you a chat solution you could have built upon without rolling out your own?
Yeah, so we did evaluate essentially vendors that provide this chat as a service, but at you know, we're talking about 85 million messages per day. It becomes cost prohibitive, right? And usually those companies, they tailor to startups. So they tailor their infrastructure to smaller guys, right? I'm building my own new app, and I want to time to market very quickly. So I'm going to partner with you. I'm going to use your SDK. Boom, I have chat. But I have maybe 10,000 people in the network. So the load is not as high. One of the things that I check when I work with a vendor is like, I don't want to be the white elephant when it comes to your client list, right? If I'm coming in and I'm the customer with the biggest amount of traffic, I need to run through the door, because I don't know if you can scale that way, right? I'm essentially trailblazing a new use case for you, and I don't, you know, I much rather be in the middle, right?
So second that point too, thank you. For those of us working with startups, you do these RFPs, or you engage the engineering teams, these other vendors.
Yeah.
What's the revenue process for those folks? Because I don't know what your revenue model is, but I assume there's a cost associated with those.
Yeah, so they charge you, so there are different models, right? So they sometimes charge you per transaction, right, per message sent. They may charge you per volume in terms of like the data exchanged. So there are different, it's essentially a pay, you have to pay to play type of thing. and it's very similar to Amazon, right? I mean, Amazon charges you per usage, right? So it's very similar. Okay, so
One question.
what's up?
Real quick, it's more like a geopolitical question. So it's basically, I just learned about this app a few days back. So my question to you is, I'm sure
Really?
there's, yeah.
Just kidding.
There's a few, I mean, this worldwide, I'm sure that people all over the world, they would like to use this app. How do you circumvent in certain countries that are prohibiting, you know?
Very good,
yes.
very good point. So that's kind of moving towards security area, but I can tell you that, so we know that certain countries in the world try to hack our APIs to mine them and find gay people to prosecute them, right?
Which is very sad, you know.
Yes. And the reality is that we live in a world where there are countries in the world, if you're gay, you can be stoned to death. Right?
Yeah.
It's not an ideal scenario. So we essentially have this concept of bad neighborhoods, and if you decide to hop on a plane and let's say fly to Egypt or Iran or some other Russia, for example, if you end up going to Russia, what ends up happening is that we prevent certain information from being exchanged between client and server, right? So you get reduced functionality. You cannot be found. You cannot be triathleted, for example. But you still can use the service. Right?
What if users use VPNs or proxy servers? Is that something like that?
So the problem with that is that if you're using a VPN, then you're not seeing people around you. Right? And the whole point of the app is like you want to see who's around you to meet them, right?
Unless there's kind of some kind of like secret tunneling, or there's a way where everybody can meet up and they know that okay, they'll be flagged from these restrictive countries, but hey.
Right.
You know.
Right. Okay. So again, going back to our presentation, list of technologies. This is the setup. Let's move on to this. So this setup is not ideal because it's not high availability. All the writes end up here. So if my, if East Coast of the United States goes dark, then I'm pretty much screwed, right? So the answer to that is really a setup where you have autonomous data centers, right? And what you need to end up doing is essentially you need to get into this multi-master state synchronization and replication, right? So we're actually leveraging DynamoDB. DynamoDB supports multi-master setup. You can use streams to replicate data across. It's not something very easy to set up, but it works for us. And the whole pub/sub model when you're distributing data still works. We're at the point where we're starting to tweak policies in terms of what state we can replicate where. Because now if I'm doing writes here, to your point, if I'm writing here, then I don't have to wait. Whoa. Okay. Scrum time. Okay, let's go back. So, what was I? Okay, so if I'm writing into a local data store, then the synchronization is actually much faster, right? So the latency is reduced for the users here. Right? Now, a couple of things. I mentioned that we are transitioning off a couple of technologies. I mentioned that we're using Redis labs for this piece. The piece that's not shown here is the Elasticsearch with QBox. This is now Cloud AMQP, and we're heavily using DynamoDB. We're still using RDS, but we're phasing it out. We're actually considering to use Neo4j also for our social graph data. We're actually looking for a vendor, a managed Neo4j vendor to kind of partner up with, because again, I don't want to have a very heavy DevOps footprint to manage my own Neo4j cluster, right? We did consider Cassandra at some point, but Cassandra is a nightmare to scale. Very, very, very good product, but again, it requires very heavy DevOps overhead. Okay, and the last thing I want to talk about is after this slide. So this is kind of shows you how the replication works. So you have API endpoint, you hit the service, you establish your transaction boundary, you write to your persistence, everything is fine. Then you have your replication publisher that essentially says, okay, I need to publish this data now onto a topic. And then your transaction commits after all that stuff happens. You return 200 to the client. But then you've got a whole bunch of consumer subscribers here that essentially take away from the topic and then update these local Redis instances.
Are you using Redis for the pub sub or are you using AMQP?
We're using AMQP. Okay, and the last thing when it comes to scaling this thing. So let's go back. So let's say you achieve all that stuff and you want to push it even further. Now you can start talking about leveraging CDNs, right? So using CDN for static content, that's no-brainer stuff, right? If you have things like images and all that stuff, fronting all that stuff with CDN is very easy. We actually use Akamai. We used to use Edgecast, but because we're global, Akamai has much more POPs in the world, so their service is much better. Also, the reason why we picked Akamai is because Akamai offers object-level invalidation capability through their APIs. Why is that important? Because the next phase of this, if I want to squeeze additional performance, I will actually start fronting my dynamic APIs with a CDN, which means that dynamic data will be cached by the CDN all around the world, right? And when someone does a write, then I'm going to essentially use the CDN's API to invalidate that state in their network, right? So I'm adding additional caching capability in front of my RESTful APIs, right? But that's really, it's not easy to do, right? Yes, sir?
If you're going to do that, so are those CDNs public?
What's that?
Are those CDNs public?
Is the data public?
Yeah.
No, so you essentially change your security scheme so you can still secure your APIs, right? You still need to have some sort of a security token in order to be able to talk to them.
Can you explain how that's different than S3?
What's that?
Why wouldn't you use S3 for that? Because you could use S3 plus.
So I'm talking about dynamic data. I'm not talking about static data. So static data is easy. I can store my pictures in S3, but I'm talking about, let's say, profile data, right? So profile data, you've got an object that has headline, your first name, last name, all that stuff. That lives in a database somewhere, right? And you have a RESTful API that you need to call to get that data. Right? That RESTful API can be fronted by a CDN, which means that the JSON object that gets returned is actually cached and distributed, right? So it gets even closer. But the problem is if I do that, then if you go and update that state, then you need to have a way to essentially flush that cache very quickly. So a good company to do that is also Fastly. So we are talking to Fastly. Fastly is able to invalidate state within 150 milliseconds across the world, right? And it's very, very, very important. Now, again, when you're designing your application, you also design for the fact that nothing happens instantaneously, right? So if I update my headline, then if I'm fronting it with the CDN and I have replication of data behind, there's a lag, right? So let's say it takes 150 milliseconds to invalidate, plus maybe half a second to replicate. So there's a lag there, right? But as you're designing your architecture, cloud architecture, you kind of have to walk through those use cases, and it's really a business decision, right? Because you can reduce that time, you can compress that time for replication as much as you can. It'll never be instantaneous, right? There's always going to be some delay, but the closer you get to like this millisecond type of replication, your cost just skyrockets, right? Because now you're talking about some crazy technologies.
So how long does it take you to invalidate in Akamai? Because you could have done this in CloudFront. CloudFront is
in
like 15
Akamai, we
minutes.
have not tested that yet.
Okay.
I don't know.
And you looked at CloudFront, or?
We are looking at Akamai. So CloudFront does not offer object level invalidation yet. I don't believe. Maybe they do now, but as of 6 months ago, I don't think they did it. So if you want to invalidate, you can invalidate a whole bunch of stuff at the same time. But if I have an object with specific UUID that I want to invalidate,
Okay.
so I know Akamai does that. Fastly is actually doing that very well. But we'll be looking at others as well. Okay, so we talked about that, and that's it.
Thank you. That was Lukas Sliwka, CTO of Grindr. We're not done yet, though. There is a bucket passing around. There it is. Okay, you can all win a beautiful new drone. And all you gotta do is put your card in the bucket. If you leave, you don't win, though. So please pass this around. And we're gonna take maybe 1 or 2 more questions because we're running a little over the time. But then afterwards, Lukas will be here for one-on-one questions, so everyone has a chance to ask. Also, I'd like to ask everybody to please photograph and post it up to the meetup page. You should be able to do that shortly after the meetup is over. Everyone who is a member of the meetup can do that. So let's take the next question. Yes, right up there.
Yeah, I was just wondering what kind of technical expertise you prefer to keep in-house.
I would say if you're a Java, Scala developer, I love polyglots, right? I love people who are in a startup environment. I'm gonna go off on a rant probably right now. But in the startup environment, you need a very specific type of people. You need essentially people who are masters of jack of all trades and masters of few, right? So someone who is willing, and the way our teams are set up, we actually have full stack development teams that are pairing, right? So I've got client teams that also, so let's look at our iOS development team. You've got designers, you've got front-end iOS developers, you've got QA automation, you've got back-end, right? And they all pair, which means that a back-end developer could be pairing with the iOS developer, right? And they're kind of, you need to be comfortable with looking at the code that's maybe not your forte and kind of like, exchanging ideas and learning new stuff. Which means that I'm not really looking for this rock star developer that's like, oh, I am Java only all the way and I can kick ass. What I'm looking for, I'm very happy with a mid-level guy who is good in Scala, Java, and iOS, right? And they're willing to learn. And you have that attitude of like, you love engineering and you want to kick ass, right?
You mentioned Akka, but you didn't talk much about it. Do you have a managed service a vendor for that? Or
no, so there is a I'm drawing blank. I'll look it up for you. There's an actually, so Akka is a framework. It's essentially non-blocking I/O type of framework that uses this Whisper protocol for objects to be able to talk to each other, right? And there's a company that stands behind it, but it's an open source thing.
Yeah, I'm familiar with what Akka was. I'm just curious how you decided to implement that and in terms of at what level. Right.
So Akka is at the core of our. Are we gonna go to the moon? I don't want to say that. But so when it comes to Akka, the reason why we decided to use Akka is because it's based on Scala technology, highly scalable, compatible with Java. You can build enterprise systems, non-blocking I/O. We evaluated a couple other frameworks, but at the time it looked like the right combination of components to deal with the scale, right? There are some people that are like, oh, you gotta go, Node.js and all. At this scale, it's very difficult to build node applications that can scale to, let's say, 10,000 API calls per second. Right? And moreover, you can do it, but my question is, am I able to be able to attract the talent and the engineers to build it, right? Node.js hasn't been around for that long to generate enough pool of engineering talent out there for me to be able, like, oh, I need to hire a node solutions architect that's gonna just go to town and design this thing for me. Right? There's just not that many people out there. Larger companies, they like LinkedIn, for example, Facebook, they have their own internal labs type of groups, and a lot of times what you see when they are running Node, they modify the crap out of the kernel behind it. And it's all C, C++ stuff to squeeze that performance.
Before I take the next question, has everyone had a chance to throw their card in the bucket? Anyone raise your hand if you didn't? All right, yeah, there's a few people. Can you get that bucket and just send it all the way to the back of the room? It hasn't made it today. Thanks. Okay, next question. Right there, purple shirt.
So what's the experience like working with a set of vendors out there like that? So let's say that your app is just down, and then all of a sudden, so who do you call? Or when do you decide to call?
Oh, if something goes down?
Yeah, it's just debugging problems.
So as part of your negotiation and the contract, you also have to build in your support and SLAs and all that stuff. So one of the things that we do is that whenever we negotiate that sort of contract, I make sure that they can actually have a 15-minute SLA on set once, and then you test it. You go in and you pull the plug on your staging environment and see what happens. Right? And you do it enough times where you're like, oh, this is actually cool. They actually answer my phone, which is great. And then you go to production. Right?
Yes.
Where do you host your chat servers?
Chat servers are in Rackspace, dedicated hardware.
Yes.
Did you have any specific data, like security concerns related to Redis?
To Redis?
Yeah.
No. No, I mean, as long as you set up your cloud architecture in the way, so you have your VPC set up, you've got policies set up, you lock your stuff, you set up your subnets correctly, and if you use VPN tunnels between the vendors, and I think you're good to go. Yes, sir.
How do you back up all your data? I mean, it sounds like it's spread over different services, different locations.
Yeah.
But is there like another repository used just in case, like whatever profile names or these are customers?
Yeah. So we do backups of all our stuff. It depends how transactional the data is and how fast it changes. So these windows vary, but if we were to have catastrophic outage, I can at least go back probably 12 hours now. So.
Okay, time for one more question. Yes.
Yeah. A lot of these social networks are leveraging things like, buy your friends a gift for like $1, like a stuffy or bear or whatever. Is there any plans to monetize the app such that people could send each other some sort of gift or?
So I can't speak for product, maybe. All I can tell you is that from the engineering perspective, the way we're designing the new platform, I want to have a very granular security roles. Right now, for those of you who are not familiar with Grindr, you have Grindr Free and Grindr Extra, right? And it's essentially, for Grindr Extra, you buy a subscription and it unlocks a bunch of features, right? But I do want to have an ability to have a very granular permission model. So if you want to buy, let's say, I don't want to buy a subscription, but I want to buy unlimited blocks or whatever, you should be able to do that, right? And if I have that platform in place, then that means I can set up a whole bunch of other products, and we can also facilitate that, right? But in terms of like the actual product roadmap, the next year we don't have that there.
Okay, where is that bucket? Someone's got to win a $500 drone. Awesome. Thank you very much. Okay, may I ask? Read the shaking. One of you to just mix it up. One of you guys to mix it up. All right. You close your eyes, pull it out. Read it.
We do, but it's only for cash.
Alex Poon, you won. Wait, right back in. And I do want to give a special shout out to Virginia Wang, who has the most creative made-up card ever. Virginia, are you still here? There you are. So she will get a T-shirt sent by Redis Labs if they agree. I hope so. In any case, can I have a great big round of applause? Thank you very much. Lucas is here for one-on-one questions. Feel free to come up and ask.